Okay, so here's a take-up. If you check the chart out, feel free to pause the video, match up your results with my results. I'm going to quickly talk about some common things that we see from here. You should have noticed that like we had for our linear function, we had point symmetry. We talked about that from the second video. In our quadratic, our degree 2 polynomial, we had the two n behaviors pointing up. As x goes to infinity, y went up. As x went to negative infinity, y went up again. We had line symmetry there. We talked about that. Now when we graph the cubic in Desmos, so I have a degree 3, it should have, the n behaviors should have been identical to your degree 1 polynomial.
Mrs. Crooks-Mulder, please contact the office. Mrs. Crooks-Mulder, please contact the office.
Okay. And also, it was point symmetry. Now, if you try to think about it as it goes up to infinity, as x goes out to infinity, and y is going up, you could grab that part and rotate it around the origin, and it would fall right on top of the negative portion of the function. So it had point symmetry there. And what you should have noticed here is all of the odd degree polynomials had the same. They looked the same. They all had the same n behavior. And they looked relatively the same. You should have also noticed all the even functions, or sorry, the even degreed functions relatively look like a parabola with some slight differences, mostly being a little bit wider in some places. Okay, so check your n behaviors versus mine. Check your point symmetries. You would have also noticed all the evens were line symmetry. All the odd degreed polynomials were point symmetry. Okay, now check here this table versus your table. Feel free to pause it. We want to kind of get out of how the leading coefficient changes things, specifically the sign of the leading coefficient. So I've got the degrees here. This cubic looks like the cubic from the one above, but it's been stretched by a factor of 2. So it was a little skinnier, but the n behaviors would have been identical to the cubic n behavior in the last table. The sign of that leading coefficient was positive. Now we graphed it with a negative leading coefficient, and what we know from our grade 11 years, or a grade 11 year, is that when we have a negative number out front of that leading coefficient, we have a reflection in the x-axis, so which means that our n behavior has been flipped. So now as x goes out to infinity, y is going down. And as x goes out to negative infinity, y is going up. So the two n behaviors have been flipped, and that's with a negative sign for the leading coefficient. The same is going to be true with our even degreed polynomial. I've got an 8x to the power of 6. I have my n behaviors going up like they would have in the last table. Got a positive leading coefficient. When I had the negative coefficient, notice both my n behaviors are going down. They're going down to negative infinity. They've been flipped upside down. Same with this. I've got a negative leading coefficient for this one, and the opposite n behavior is going on with the fifth degree. Same here with a degree 10 polynomial. It's a positive leading coefficient, so our n behaviors are both going up like a parabola would. Okay, so let's just generalize it with a note. So we say, how does the degree affect the graph of the polynomial? We could say even degreed have n behavior that goes in the same direction, up. We could say odd. Over here we could say odd degree. Opposite and behavior. Okay, so they all looked about the same. We could do a quick sketch here for our even degree polynomials on my axis. All the even degree polynomials kind of look like a parabola depending on the width down there. Some were really flat down there and some weren't. And our odd degree polynomials all kind of looked like a little bit like that cubic, kind of scooted in here, and it was either flat or wide and then scooted up that way. And these are with positive leading coefficients. Okay, so our note here is, how does the leading coefficient change things? If the sign of the leading coefficient is negative, the graph is reflected in the x-axis. It's upside down. So that means that the normal end behavior is now going to be reflected. If it was going up, now it's going down. If it was going down, now it's going up. The sign is all that we're really going to focus on here. The actual number just means, like we've discussed in grade 11, it's a stretch or a compression. Okay, so let's just do a quick example here, and then I'll let you try the quiz. So we're going to sketch this. We're going to do some very rough sketches. Okay, so very rough sketches on here, and you can do them in your notes, very rough. I'm going to state the end behavior too. So here's what I look at. Let me draw a quick axis, right? So this is how rough we're talking about. So notice it's a fifth degree polynomial. That means it's an odd degree polynomial. It's going to, normally it would look like the cubic. Normally it's going to scoot in here and scoot up. That's what a fifth degree polynomial with a positive leading coefficient would look like. It's negative, which means we've been reflected. So our function is going to have opposite end behavior to this function. So this has been reflected up here, so this one's going to come down and scoot in and then scoot out. So the green function here is a really rough sketch of this function here, -4 times x to the power of 5. So our end behavior we would write like this. As x approaches infinity, the y's approach negative infinity. As x approaches negative infinity, so as we're going from right to left into the more negatives, alright, so as we go this way, from right to left, the y's are going up. And that's it. Alright, give it a shot on the quiz.